I also want to introduce to you what we have as the revolving nose piece. The revolving nose piece ensures that these objective lenses are first held in position, and as well ensures that these objective lenses can get turned from one objective lens to another, depending on what you want to use in terms of what you're actually trying to cover in terms of that particular experiment. For example, you have what you call the lower power objective lens, the medium power objective lens, and the high power objective lens. So the revolving nose piece will hold these lenses in position, ensuring change from one objective lens to another. As I've told you, these lenses can have a medium power, a high power, or a low power. So at the end of the day, you can actually be able to have these lenses being able to magnify or enlarge the specimen. You see, so they magnify, enlarge, or bring that specimen into a sharper focus. So purposely to magnify, enlarge, or bring the image into a sharper focus. So it contributes to the magnification of the specimen. So it depends on what you want to actually observe. At the end of the day, these lenses are of different magnification. We have the stage, which is just a flat platform, and this is where we always place what we call the microscope slide, onto which the specimen is placed. So you can have this stage, is a flat platform where the slide is placed, and a specimen as well placed, so that we will be able to make our observation. We have what we call the clips. The clips will keep this slide in position, ensuring that the specimen is able to get placed or get put in a particular environment within this field of view, so that the observer can be able to make a clear observation of this specimen. So these clips will keep the slide in position on which the specimen is placed for the purposes of observing the specimen. And then you also have what we call the eyepiece lens. This is where the observation gets made. And these eyepiece lenses, as you can be able to see, will have this microscope getting placed in this position, so I can be able to observe this specimen from this end. So at the top here is the eyepiece lens, or the eyepiece lenses, where observation is made and where we can also have the specimen getting enlarged or magnified. So two very important areas to have actually the specimen getting magnified: objective lenses and eyepiece lenses. We have different types of magnifications to contribute to the magnification of the specimen. We have the body tube. The body tube will hold the stage and these other parts of the revolving nose piece in position. So the revolving nose piece and the stage are held in position by the body tube. Correct. So this revolving nose piece and this stage is held in position by the body tube. Okay. We have the arm. The work of the arm is to ensure that the microscope is carried from one place to another with an effective aspect of it. So, look at this. We talked about the body tube. And you say the work of the body tube, this one here, you can be able to see, is to ensure that these eyepiece lenses and this revolving nose piece are held in position. So, the eyepiece lenses and this revolving nose piece are held in position by the body tube. The arm ensures that this part and this stage are also able to get held in position. Okay, so if you want to keep these eyepiece lenses and this revolving nose piece holding the objective lenses in position, you need to have a body tube. The work of the arm is to support the microscope, as we'll be able to have the microscope getting carried from one place to another in an effective aspect of it in terms of causing any negative damage to it. And so we are actually able to say that this arm will support the stage and the base. So the stage and the base are actually kept in position by this arm. We have what you call the mirror. And of course, if a microscope uses light, then you can actually be able to have the mirror reflecting light onto the stage. Correct. So the mirror ensures that light is reflected onto the stage for the purpose of ensuring that the specimen is well illuminated. So this can serve as our mirror to reflect light onto the stage so that the specimen can get observed. And just at the bottom here, we have what we call the condenser. The work of the condenser is to concentrate light onto the stage for the purpose of illumination. And of course, we have what we call the diaphragm, which is an aperture that ensures that the amount of light reaching the stage is regulated to prevent an excessive amount of light reaching the stage and causing some blood getting formed on the stage. So we can talk about the diaphragm regulating the amount of light reaching the stage, and as well the condenser concentrating light on the stage for the purpose of illumination. And purpose filters can just be the most important ones we can be able to mention as far as our microscope is concerned, and not forgetting about what I've just talked about in terms of the eyepiece lens and then objective lens contributing to the magnification of the specimen to ensure that the specimen can get put into focus. Thank you so much for your time, and you have a lovely day.